I am going to draw again this six-sided figure, and I draw a bigger circle. So this six-sided figure that we're talking about, it's really called, who can remember? Yes, it's called a hexagon. So now in a six-sided figure, and you'll see this in several of our discussions, is just goes to show that all the triangle form, if you draw a line from the center all the way to one of these edges, that touch the circle, all the triangles that are formed are essentially equilateral. So this means that in an equilateral triangle, that this side and this side and this sides are all the same. So now we know that this is a unit circle and the diameter here is pretty straightforward. The diameter here is 1. And so that makes the radius, from here to here or from here to here, 0.5. And just by looking at this, we know then, and it's very easy to calculate the perimeter of the hexagon. So here, I can tell you now what the perimeter is of this hexagon. So here, the perimeter of the six-sided figure, the hexagon, it's not visible. Let's write it a little bit below. The perimeter of the six-sided figure is, you add all the sides. So you add all the sides, or 6 times that side. And so you can see now that this side is, by logic, should also be 0.5. So if this is 0.5, the radius, since this side is the same as this side because it's an equilateral triangle, therefore all the sides here has a value of let's just write it in here, 0.5. And so 6 times 0.5, your answer is 3. Yes, and that's why you have a perimeter of 3 in a six-sided figure in a unit circle. Now we proceed to the next part, as I promised, is move from six-sided figure to 12-sided figure. Okay, so sorry for the long wait, but I have to do something. Okay, so now what did Archimedes do? So we know that the perimeter of the hexagon is 3. And I did say that how did he move from a six-sided figure to 12-sided figure? Well, it's very straightforward. It kind of, he locate the midpoint of this, and ideally we use a compass to do this. It's much faster, but yes, that's all we got. So, and then he connected this from here to here. So from here to here. So basically, doubling the number of sides. So we'll take some time. Now, not a lot of people nowadays do this because everybody seems to be just doing the computer. You use a MATLAB. I always love this because it slows it down. So here you have a 12-sided figure, a dodecagon, and you can see that the perimeter of this should be so close. The perimeter of this figure, this 12-sided figure should be so close to the perimeter of the circle. And how do we get the perimeter of the circle? And this is where the whole thing really becomes a little bit complicated, but not too complicated. I'm going to rub this out. Yes. So I'll just have to make a note in here that the perimeter of the green drawing, the perimeter of the 6-sided figure is 6 times S, which is really the 3. Which is really 3. There. I hope you see that. Right. So now, how do we solve this? Let's do this figure in here. So we know this side. How do we know this? But we kind of create, but we don't know this. Yes, that's what we want to solve, is this figure in here. Now we need to know another side, and we need to know this side, right? So to be able to solve the whole question. So what is the length of the red line? We don't know. Yes, so we call it red line A. Yeah, let's call this red line the side A, and let's call the green line as B. Yes, or B over 2, or let's just call this B. And the object we'd like to find is side C. Now first, we want to find out what that red line is. Well, the only way to find it out is to really extend this line a little bit further, right? From here all the way. And we know that the black line plus the red line is essentially the radius. So to make it a little bit visual, so here the radius is 0.5. And the radius is essentially, line A plus the black line. What do we call this black line? Oh, wait, maybe we call this line D. Yes, plus D. So we can solve for A. So if radius is 0.5 and A is, we don't know. We don't know what A is, and we don't know what D is. I thought it was really straightforward. So there are two things we need to solve. We also need to know what the value of this, D, to be able to solve for A. And so our job for now is, what is the length of D? That black line. Let me redraw this. I thought it's going to be straightforward. I forgot that there's an extra step. I haven't done this for quite some time. So let's redraw this here. I hope you can see. So the black line here is this one. And the green line is this one here. And there's that other green. There's that other green line. There. Now this green line is also the radius. That's also from here to here. That's also 0.5. And so we don't know what D is, but can we get this line B? How do we get this line B? Well, we know because that line here from here to here is also, it's also 0.5. Why? Because all of this is an equilateral triangle, as I've said previously in my session. So all the lines here have the same measurement because they are equilateral triangle. So the B here is really radius divided by 2. Yeah, so that will be radius, well, we could say 0.5 divided by 2. Now what is 0.5 divided by 2 is 0.25. So now we know the value of B. Now we can solve for D. Through what? Yeah, remember, that's a right angle. That's Pythagoras. So the length of two shorter sides, which is B and D, the square of this side, let's just do the Pythagoras now. The square of this side plus the square of this side is equal to the square of this side, which happens to be the radius here. And so we substitute the values of B, which is 0.25 square plus D squared equals, what's the radius? 0.5 square. And so we solve for the values of this. So 0.25 square is 0.0625 plus D square plus 5 times 5, yeah, is really 0.25. Now, how do we get rid of this, yeah, number? We only want a letter on the side, so we take it away. And what we do to one side, we do to the other. 0.0 or 0.0625. So this one cancels, that becomes a 0. We bring that one, D square. And so 0.25 less 0.0625, and your answer is 0.1875. And of course, we get the square root of this. So D is equal to the square root of 0.1875. The square root is, the answer is 0.43. Yeah, two significant figures. Let me just check this again, because sometimes I do make some mistakes. Yeah, what? Yes. So the value of D is 0.43. So here this is 0.43. And now we can calculate for that red line, yeah, which is in here. So now we have this, yeah. We have this. Let me just rub the other ones. Let's rub this one. Yes. So 0.43. That's the value of D. So here, let's just write that. Yeah. So we have here again, we can substitute A equals A plus what is D? Is 0.43. Yeah. What do you add to 0.43 to make this? And that's your value of A. But the algebra would be, you want to get rid of this number here and we only want a letter. So we have to take away 0.43. What you do to one side, you do to the other, which is also 0.43. And of course, bring that down, which have A. This one is 0. So 5 less 0.43 should be 0.07. So 0.5 less 0.43, your answer should be 0.07. 0.07. So A is 0.07. So now you have a value of A there. So here, this one, so this one, this value of A is 0.07. Now, since we have the value of A and we have the value of B, now we can calculate for Z, letter C. So that took a long time to really do it, but I need the space to draw this question again. So let me rub that out. Let me rub this out. So I'm going to draw this one again. So this line here would be here. Now let me just keep the same color. Make it bigger. This line here, yeah, that's the side of this 12-sided figure. That's one of the side. And then finally, we have this line here, which is the B side. And how do we get this black side, this letter C? Well, again, Pythagoras. The length of this shorter side. So this is A. The square of this side plus the square of this side, we add together, is equal to the square of the longest side, which is the hypotenuse. So we're going to write the formula of that. So it's going to be A squared plus B squared equals C squared. We have our A, we just solved for it. That A there is 0.07 square plus the B, we have the B. The B is, there you go, 0.25, half the radius. So 0.25 square equals C squared. Of course, now, I always show you, some of you wanted me to show you through the calculator, 0.07 square. So it should be 49 with 2 decimals, 7 times 7, and then 4 decimal places. 1, 2, 3, 4. It should be that. Plus the square of 25. 0.25 square is 0.0625 equals C squared. We add this value, which is 0.0049 equals, should be, C squared should be 0.0674. And we get the square root of this number. Get the square root of that. And your answer should be C should be 0.25, well, two significant figure, two decimal places, so it's 0.26. And that's your value for C. Yeah. And from that, we can calculate the perimeter. So the perimeter of a 12-sided figure is, you add all the sides, yeah, which is 0.26. So the perimeter, yeah, let's put it in here, yes. I'll rub it out. So in here, the perimeter is of a 12-sided figure is 12 times its side. Yeah. And 12 times its side is 12 times 0.26. 0.26. And your answer to that, yeah, is 12 times 0.26. Your answer is 3.12. 3.12. So now we're getting closer to the value of the pi, which is also the circumference of the unit circle. That's what I want to discuss next, is why are we calculating for pi when we want to know the value of the perimeter of the circle? That's probably a good question, because I know one of you asked me that. So that's going to be the video for the next session. Thank you so much, and I hope you learned something.